Dear students, we are going to discuss about truss analysis using method of joints in strength of materials. In this lecture, we are going to talk about objective truss, types of truss, applications, perfect frame and imperfect frame, truss analysis and method of joint. Objective of this lecture is to determine the member forces in the pin jointed plane trusses using method of joints and to find the frame whether perfect or imperfect frame. A truss is a structure which is made up of several bars or members riveted together or welded together in which the loads act only at the joints and not on the members. The truss is made up of bottom chord member, top chord member, and diagonal member and the purlin in which the load will be acting at the joints only. It is used as roof trusses to support sloping roofs and as bridge trusses to support the deck slab. So here we can see the diagram, the sulfate of the seeds which is transferred to the purlin and purlin to at each joints as axial forces. A truss in which all the members lie in a single plane which is called as a plane truss. The application of the truss, that is bridge truss, roof truss and transmission towers. And this is the types of truss which is perfect truss and imperfect truss. Imperfect truss is divided into deficient truss and redundant truss. So if you see perfect truss, a pin jointed truss which has got just sufficient number of members to resist the load without undergoing any deformation in shape is called a perfect truss. And also a truss which satisfies the relation, that is m is equal to 2j minus r, is called as perfect truss, where m is number of members and j number of joints and r is reaction. We see the example in the first diagram, number of members is 3 and number of joints is also 3. So if you substitute in the equation, you will get 3 is equal to 3. So therefore it is satisfy the equation. So that is known as perfect truss. Then imperfect truss, a truss which does not satisfy the relation, that is m is equal to 2j minus r, is called as imperfect truss. If you see the diagram, here the number of members 8, number of joints 6. So therefore if you substitute in the equation, you will get 8 less than 9. So therefore this type of truss is known as imperfect deficient truss. Then the second type is imperfect redundant truss. A truss which satisfies the relation, that is m greater than 2j minus r, is called a redundant truss. If you see the diagram, here the number of members are 10 and number of joints is 6. So therefore you will get a 10 greater than 9. So then it satisfies the relation, that is m greater than 2j minus r. So therefore this type of truss is known as imperfect redundant truss. And also the types of truss can be classified as based on the arrangement of members, that is king post truss, scissors truss, broad truss, hoof roof truss, saw tooth truss, fink truss, and barren truss. So based on the arrangement of members, we can classify the trusses. And this is the assumptions to be followed for finding the members forces for using method of joints, method of section, and tension coefficient members. That is, the ends of the members are pin jointed, the loads act only at the joints, and self weight of the members are negligible, cross section of the members is uniform, and frame should be perfect. For analysis of pin jointed plane trusses, so there are three methods are used, that is method of joints, method of section, tension coefficient method. So in this lecture, we are going to discuss in detail about method of joints. The procedure for analyzing the method of joints, first step is we go to draw the free body diagram of the entire truss. Then second, we go to apply the static equilibrium equation for finding the support reaction. And the next, we go to consider the free body diagram of the joint in which only the two member forces are unknown, and we go to assume the member forces are either tensile or compression. Then we go to apply the static equilibrium equation, that is summation of B is equal to 0 and summation of H is equal to 0 for finding the member forces. So if the answer is positive, our assumption is right. If the answer is negative, our assumption is wrong. We go to change the nature of the force. And select a new free body diagram of the joint, at which also we go to check the joint in such a way that only two member forces are unknown, and we go to repeat the points 3 and 4 for complete the analysis for finding the member forces. And finally, we go to tabulate the answer representing the member forces and magnitude of the force in kilonewton and the nature of the force. And here we can see the example of cantilever truss and finding the member forces using method of joints. For cantilever truss, we need not find the support reaction. We can directly find the member forces. First, we go to find the angle from the vertical distance and horizontal distance. Next, we go to select the joint at which only the two member forces are unknown, and we go to apply the static equilibrium equation, that is summation of B is equal to 0 and summation of H is equal to 0 for finding the member forces. So if you see the joint C, the unknown member forces are CB and CD. So we got to resolve the forces in vertical and we got to resolve the forces in horizontal direction. So we will get the member force FCP 42 kilonewton and FCD is 40 kilonewton. So here our assumption is right. So therefore we can keep the same nature of the force, tension and compression. And similarly, we got to repeat the same steps for we got to choose the next joint in such a way that only the two member forces are unknown. So if you see the diagram, we can select the joint, that is joint D. So there are two member forces are unknown. So we go to repeat the same steps for finding the member force, unknown member force, that is FDP and FD by applying static equilibrium equation, summation of B is equal to 0 and summation of H is equal to 0. So similarly, we go to repeat the same steps for all the members through by selecting the individual joints in such a way that only the two member forces are unknown, and we go to apply the summation of B is equal to 0 and summation of H is equal to 0. So we will get the member forces for all the truss. Finally, we go to tabulate the results in the form of member, magnitude of force in kilonewton, and nature of force in tension and compression. So also we go to represent the diagram in the form of tensile and compression. So to represent the tensile force and compression force, the indication of the diagram by in the form of for tension, the member forces which is pushing the joints. For compression, the nature of the member forces which is pushes the joint. For tension, the member forces in the pulling the joint. So in such a way that we go to indicate the results in the diagram. So I hope this lecture will be useful for all the students for understanding method of joints. Thank you.